Hello children, today let us start class 8 mathematics chapter 3 recapitulation of understanding quadrilaterals. Here we are revising understanding quadrilaterals. In this some of the basic concepts are given. First thing is a closed curve. What is a closed curve? A figure in the plane with no endpoints. With no endpoint, that is there is no endpoint. Once you start drawing a curve, if it doesn't have any end point, such curves are called closed curve. It may be an oval, it may be a square, whatever it is. Such a figure which doesn't have any end points are called closed curve. Second, open curve, a figure with end points. For example, you draw a curve where you have end points. Where you have end points. Such figures are called open curve. Now let us move on to the polygon. A simple closed curve which is made up of line segments. Which is made up of line segments are called polygons. Polygons in the sense, poly means more, gon means lines. A simple closed curve which is made up of line segments. If all the sides may be different, all the sides may be equal. Again further we have classification in that. But here only if it is referred to only polygon, a simple closed curve which is made up of line segments. Now in this we have classifications of polygons depending on number of sides. If it is a three-sided polygon, it is called as a triangle. It is called as a triangle because here three line segments are used. 1, 2 and 3. 4 line segments are used, then it is a square. 5 line segments are used, then it is a pentagon. 5-sided. Now, if it is a 6-sided polygon, then it is a hexagon. If it is a 7-sided polygon, then it is a heptagon. One, two, three, four, five, 6, 7. Now, if it is 8-sided, then it is a octagon. If it is a 9-sided, then it is a nanogon. Nanogon. It is a 9-sided. One, two, three, 4, 5, 6, 7, 8, 9. So now these are the classification of polygon and number of polygons are given here. Now let us move on to diagonals. A diagonal is a line segment connecting two non-consecutive vertices. Two non-consecutive in the sense which are not adjacent. Here. These are the two vertices which are non-consecutive, and this is the figure given here, and this is the line segment which is called as a diagonal which connects these two non-consecutive vertices. And here also same thing, first one and second. These are the two non-consecutive vertices which are joined by this diagonal. So in this diagonals we have so many number of diagonals in each of the polygon that you will learn later. First, in this again there is a specification in the polygon. Convex polygon and concave polygon. There are two kinds. First one, convex polygon. All the diagonals exist inside the polygon. That means once you draw a polygon, the diagonals must exist inside the polygon. Those are called convex polygon. Concave polygon don't have all diagonals inside the polygon. That means if there is a polygon which doesn't have all the diagonals inside may be somewhere in the exterior part of the polygon. Such are called concave polygon. Now let us move on to quadrilaterals, which is the main concept in our chapter understanding quadrilaterals. A quadrilateral is a polygon with 4 sides, 4 angles and 4 vertices. Here this is a quadrilateral. This is an irregular quadrilateral because all the sides are not equal here, but it has 4 vertices A, B, C, D, 4 sides A, B, B, C. Vertices are A, B, C, D. Sides you can call those are edges also. A, B, line segment, B, C, C, D and A, D. And 4 angles. 4 angles A, B, C, D. Angle A, angle B, angle C, angle D. So this is the property of a quadrilateral. A quadrilateral is a polygon with 4 vertices, 4 angles and 4 sides. Now let us move on to angle sum property. What is the angle sum property? Now we know what is a quadrilateral. It has 4 angles. And now we will learn about sum of its angles. So here I have divided this quadrilateral into 2 triangles. So if you draw a diagonal, it will be like a 2 triangles. First triangle is DCD and second triangle is ADD. That means we have 2 triangles in a quadrilateral. So if you add all the angles of the quadrilateral, you will get the angle, the total sum of the angle will be 360 degree, which are interior angles. Here we have 2 kinds. One is interior angle, the other one is exterior angle. All the angles which are inside the quadrilateral, if you add them, the sum of those angles will be 360 degree. For example, triangle BCD plus triangle ADB, which is equal to quadrilateral ABCD, which is equal to angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6. There are 6 angles, 1, 2, 3, 4, 5, 6, and the total sum is 360 degree. Now if you don't divide this into 2 triangles also, you will get the sum as 360. If you divide this into 2 triangles also, you will get the sum as 360. Now angle sum property, that is exterior angles. Once you draw the quadrilateral, how you have interior angles, in the same way you have exterior angle also. Because if you extend this line or this vertex, you will get one more angle here, which will make this as a linear pair. And this outer angle, which are called exterior angle, its sum also will make 360 degree. So angle sum property, that is for exterior angle also of this quadrilateral ABCD, is equal to 1, 2, 3, 4, 5, 6, 7, 8. Angle 5 plus 6 plus 7 plus 8 gives you 360 degree. So the angle sum property of a quadrilateral is sum of the interior angles is equal to sum of the exterior angle, which both are equal to 360 degree. Now here, sum of interior angles of a polygon with n sides, number of sides is given, then how to calculate? We have a formula n minus 2 into 180, n minus 2 into 180 to find out the sum of interior angles of the polygon. Here a polygon is given which is a 4-sided, this is called a quadrilateral. So now sum of interior angle, you have a formula n minus 2 into 180. What is n? Number of sides. Number of sides is equal to 1, 2, 3, 4. 1, 2, 3, 4. So n is equal to 4. And once you apply the formula here, 4 minus 2 into 180, that is 2 into 180, you get 360. So this satisfies our statement that interior angle property, the sum of interior angle is equal to 360 degree. Once you take any polygon with n sides, if you put the number of sides, we can calculate n minus 2 into 180, that is we have a quadrilateral here which is number of sides which has 4 sides. 4 minus 2 into 180 gives you 2 into 180, it is 360. Now let us move on to the classification of quadrilaterals. Here there are some types of quadrilaterals. In this first one, trapezium. A quadrilateral with a pair of opposite sides are parallel. We know that a quadrilateral with opposite sides are parallel. These two are parallel, A, B, C and D. AB and CD are parallel to each other. AB is parallel to CD but not equal, and AD and BC are not parallel. Only a pair of opposite sides are parallel, that means AB is parallel to CD. This is a trapezium. And here one more special case we have, in that opposite sides, a pair of opposite sides will be of equal length. One pair will be parallel and the other pair will be equal length. A, B, C, D. Here AB is parallel to CD and AD is equal to BC. These two will be equal and this will be parallel. So AD, length of AD if it is 5 and length of BC also will be 5, and AB will be parallel to CD. Such trapeziums are called as isosceles trapezium. Now let us move on to the next quadrilateral, that is a kite. We all know that we play a lot of games with kite and all in our daily life. A quadrilateral with adjacent sides of equal length. Adjacent sides in the sense which are neighbor of each other. A, B, C, D. AB and CD will be equal in length. AD and CD will be equal. AD and CD will be equal in length. AB will be equal to BC. That is with adjacent sides of equal length. These two are equal because these two are adjacent sides, and these two are equal which are equal in length. Adjacent sides, a pair of adjacent sides here with a pair of adjacent sides equal in length, and this is the kite. Now let us move on to the parallel. A quadrilateral with opposite sides parallel and equal. Here this is a quadrilateral where opposite sides will be parallel and equal, and some of the properties are opposite angles will be equal. A, B, C, D. AB is parallel to CD and AD is parallel to BC, and length also will be same, and AB will be equal to CD and AD will be equal to BC. Opposite angles will be equal in the parallelogram, that is angle A is equal to angle C and angle B will be equal to angle D. And one more property is adjacent angles, or you can say corresponding angles B and C are supplementary. These are adjacent also because after C comes B or after B comes C, because both are called neighbors. So B and C which are supplementary, that means B plus C, if you add up it will be 180. That is supplementary. These are called also consecutive angles, also you can say complementary angles which give the result as 180. Supplementary angles. Complementary is 90, supplementary is 180. Now next comes rhombus. A rhombus is a quadrilateral with all sides of equal length. Here all the sides are of equal length. A, B, C, D. And diagonals bisect each other perpendicularly. Diagonals are bisecting each other at perpendicular, and here we make it as a 90 degree. So those bisect each other at perpendicularly, we can say. So this is a rhombus. Now let us go on to rectangle. A quadrilateral with opposite sides equal and parallel. This is a simple quadrilateral with opposite sides equal and parallel. That is, AB is equal to CD and AB is also parallel to CD. AB is equal to CD. AB is parallel to CD and AD is parallel to BC and AD is also equal to BC. And here we have four angles A, B, C, D. All are 90 degree. All the angles of a rectangle are 90 degree. Angle A equal to B equal to C equal to D is equal to 90 degree. And here we have two diagonals. Both are equal but not bisect. They doesn't bisect here perpendicularly, but they are equal in length. That is, BD diagonals. BD is equal to AC, but they do not bisect each other at a perpendicular point, or you can say here we don't get any 90 degree when they bisect each other. Now let us move on to the next quadrilateral, which is a square. A quadrilateral with all sides equal. This is a simple quadrilateral, we all know, and we are learning this from our lower classes. This is a four-sided polygon. A square A, B, C, D. Here all angles are 90 degree. All angles are equal and parallel. That is, A equal to B equal to C equal to D. All are 90 degree. AB is equal to BC equal to CD equal to AD, and AB is parallel to CD. Opposite sides are parallel. That is, BC is parallel to AD, and bisectors BD and AC are equal and perpendicular. By diagonals, BC is perpendicular to AD, sorry, not BC, BD. BD is perpendicular to AC and BD is also equal to AC. They are equal in length and also perpendicular. So this is the classification of quadrilaterals, and in our next video we will move on to the exercise 3.1. So let us stop here today. Thank you.